calcium chloride solution plus sodium sulfate. So these are going to always be double displacement reactions, and you will form calcium sulfate and sodium chloride. Which one of those two products is going to be your solid?
Excuse Miss WT,
Yep.
can you submit your attendance?
Yep.
Thank you.
Yes, your calcium sulfate is going to be your solid. So then write out your equation for the equilibrium of your dissolving of your solid. Everybody's here. So calcium sulfate solid calcium 2+ and sulfate 2-. So now what you have to do is you have to figure out what your concentrations of calcium ions are and the concentration of your sulfate. You've changed the volume of your solutions when you mix them. You had 50 milliliters plus 50 milliliters of the other solution. So your final volume is now 100 milliliters. So you use C1V1 equals C2V2 to figure out the new concentration of your ions. And you do that for both solutions. So your new concentration will be your initial concentration times the volume you took divided by the new volume once you've mixed it. So for our calcium, we had .001 mole per liter. We had 50 milliliters. And our final volume is 100 milliliters. Because that's calcium chloride, now you multiply that by the mole ratio of calcium in calcium chloride. So for sulfate, we have 0.01 mole per liter times 50 milliliters divided by 100 milliliters. No, different concentration.
1 calcium chloride. How do you know it's calcium? Like the original. Yeah, but we were trying to find the C2, right?
Yes, but we're given calcium chloride. So you can't, when you calculate the second concentration, it is for calcium chloride, because that's the substance that you started with.
But then didn't we use C1 for calcium?
We used C1 for calcium chloride,
Which we already have the C. Right?
but we wanted afterwards, what's the concentration?
Oh,
But then, right, if our solid contained chloride, you would get twice as many chlorides because of the ratio of chloride to calcium chloride. So you have to do this step at the end. Yeah.
You got the equation by breaking off the AQs and then canceling out.
Yeah, just from the solid, yeah. Yeah, all the other ions are just gonna be floating around in the water. Okay. So what's the concentration here?
5 times 10 to the negative 3.
So this is moles per liter of sodium sulfate. So don't skip this step. There's 1 sulfate for every 1 sodium sulfate. So now we know the concentration of both of our ions, which is a lot of work just to start the question. Right? We just did a lot of work. Now we can calculate our Q. And now we compare it to our KSP. What's that?
So you could have told me I used the bulk space.
Oh, did you?
I know I used up all my space too. Oh my God.
Okay, so now, what would be Q? Q is a trial KSP. So Q is going to be equal to the concentration of calcium ions times the concentration of sulfate ions. You're not actually going to need very much room here at all now. So 0.0005 times 0.005. Five zeros
Then 2, 5.
and then 2, 5. So 2.5 times 10 to the negative 6. We don't need units in this equilibrium unit. So let's compare it to our KSP. What's the value for our KSP? Does it say in the question? Nope. So there must be a table in your textbook that's a table of KSP values. Compare your Q to your KSP. Is it greater? No. So no precipitate. No precipitate will form if you mix that quantity with those concentrations. You will not get a precipitate.
Are we allowed to have a textbook during the exam?
No.
I mean, you should try.
You get nothing in life unless you ask.